Today we will study post-harvest storage of fruits and vegetables. My name is Amit Mukherjee. I am Assistant Professor in the Department of Food Technology, Haldia Institute of Technology. Fruits and vegetables. Fruits and vegetables are important agricultural commodities. Those are produced in very large scale in India, and they differ from other agricultural commodities, particularly the cereal grains, pulses, legumes, etc., uh, in their moisture content. The moisture content of fruits and vegetables is very high. It can be uh, starting from 70% and can be as high as 90% or above. They contain very high percentage of moisture, but their uh, structure is very firm. The outer surface is very smooth, and they contain free sugar, lot of free sugar. The fruits particularly contain very high percentage of sugar. According to a recent report, India occupies first place in fruits production and second place after China in vegetable production. This report is given in 1997, I think, and still India occupying the same positions in case of production of fruits and vegetables. Above 10% of fruits are produced in the world. The total world production of the total world production, above 10% is contributed by India, and above 13% in case of vegetable is contributed by our country. The, they contain very high amount of water, 70 to above 90%. Fruits and vegetables are highly perishable in nature. That is why, due to the presence of very high percentage of moisture, and many fruits and vegetables, because the newer plants are born from from the seeds present within the fruits, and some vegetables which are root vegetables, etc., they contain they store the food material for the future plant. So it is highly nutritious. Nutrient content is very high. Lot of enzymatic activity is there. So everything is in favor of perishing the fruit if it is not stored under suitable condition or processed just after harvesting. They are highly perishable and cannot be stored under atmospheric condition for long time. So respiration, another thing is respiration, which takes place within these fruits and vegetables. And that is another factor which can accelerate the process of this destruction of the fruits and vegetables. They contain free sugars and starch and are next to cereal grains in supplying energy for the body. Cereal grains are staple foods for human, and we consume them for their starch content. But next to these cereal grains, we consume these fruits and vegetables, uh, and they supply the energy. They are sources of water and fat-soluble vitamins and minerals. A large number of different types of vitamins are present within the fruits and vegetables. That is why their importance in nutrition for human. And minerals, different mineral salts are present. They contain many bioactive substances as well, and fiber, crude fiber. The nutritional quality of fruits and vegetables. Nutritional quality of fruits and vegetables. Though they are not staple foods for human, fruits and vegetables are consumed in larger quantities daily next to cereals. The amount of carbohydrate in fruits and vegetables vary widely from 5 to 40%. So various uh, fruits and vegetables, their carbohydrate content vary also. Though many vegetables are eaten for their starch content, for example, potato, cassava, etc., They are root vegetables. Most of the fruits contain a juicy portion with soluble solids predominating as monosaccharides and disaccharides. More than 90% of dry matter of fruits are carbohydrate. So in case of fruits, a juicy portion is there where water as well as the soluble solids in the form of monosaccharides and disaccharides. Among the monosaccharides, it is the fructose which predominates, and fructose is rapidly metabolized within the body because it takes the pathway of fructose 1-phosphate through fructokinase enzyme, uh, just a parallel pathway to that of glycolysis of glucose. And more than 90% of dry matter of foods are carbohydrate. Though the protein content is much lower in fruits and vegetables, which is around 0.1 to 1.5%, they can compensate the need for some essential amino acids which are lacking in cereals and pulses. We consume pulses for their protein content. We do not consume fruits and vegetables for their protein content. Though the protein content in fruits and vegetables is low, they contain some essential amino acids which are lacking. That means in case of cereal grains, lysine is lacking. That is the limiting amino acids. While these fruits and vegetables can compensate the need of that lysine. The sulfur-containing amino acid methionine, lysine is abundant in pulses, but other amino acids, sulfur-containing methionine, etc., these amino acids are lacking in pulses, but fruits and vegetables can compensate that. So, though the protein content is low, they can supply the essential amino acids which are not available from those staple food cereal grains and pulses. Lipid content of fruits and vegetables are very low, 0.1 to 0.3%. We do not consume fruits and vegetables for the lipid content. But essential oils, in case of citrus fruits, the surface, the peel, contain essential oils which are terpenoid in nature, which are not fats and oils, and they are highly flavored. So these essential oils are byproduct from citrus fruits, but those are not lipids. Fruits and vegetables contain water-soluble B vitamin and vitamin C. Citrus fruits contains ascorbic acid. Ascorbic acid undergo oxidation to dihydroascorbic acid, followed by the last stage of the reaction, which forms an inactive compound. Ascorbic acid and dihydroascorbic acid are active substances. So these two vitamins are very important vitamins for our body, available from fruits and vegetables. Besides them, fat-soluble vitamins like A, D, E, K, all such fat-soluble vitamins are available from fruits and vegetables, different fruits and vegetables. A large number of different minerals also, like sodium, potassium, calcium, magnesium, iron, zinc, copper, selenium, cobalt, phosphorus, etc. are available. Even manganese, sulfur, those are available in fruits and vegetables. They are cofactors for various enzymes. Various reactions take place, and within the metabolic pathway, these salts are required during various reactions taking place within the cell. Bioactive substances like carotenoids, flavonoids, terpenoids, tannin, and other polyphenols, glycosides, saponin, etc., are present in varying amount in different sources of fruits and vegetables. They are secondary metabolic product, and they prevent the external enemy to thrive on the fruits and vegetables. So those things are produced by the plant. These are toxic substances, and this glycoside, etc., saponin, polyphenol, those are also there. Fruits and vegetables provide good amount of fibers for human. A very important fiber, which is pectin. Pectin is not digested in our body. However, pectin has its importance in food processing industries as a thickener ice cream thickener, and also jam, jelly manufacture, etc. Pectins, besides pectin, other cellulose, hemicellulose. Hemicellulose is a cell wall material which gives firmness to the cell when it is material, fruits and vegetable is treated with alkali. This hemicellulose portion is dissolved and the fruit becomes softer. So under alkaline condition and high temperature, if we treat the fruits and vegetables, the farm fruits and vegetable becomes softer in nature. The Though present in traces quantities, different volatile substances contribute to aroma of fruits, vegetables, fruits, material. So volatile substances, a large number of volatile substances which are responsible for aroma, these are lost when thermal treatment is done, extensive heating, etc. are done. They give the characteristic flavor of the fruits and also some vegetables. Volatile compounds are largely esters. They are alcohols, acids, aldehydes, and ketones. Acids are there, succinic acid, the citric acid, the oxalic acid, malic acid. Malic acid is abundant in different fruits, aldehydes and ketones, lactone. These give characteristic flavor to the fruit. However, the fruits and vegetables are lost. Post-harvest loss is enormous in case of fruits and vegetables. Though we produce very high amount of fruits and vegetables every year, but due to lack of facilities of storage and processing, we lose huge quantity on the field and off the field. So that is a major problem with fruits and vegetables. Economy in the agriculture, related to the economy of the agriculture. Immediate storage under suitable condition. We must store them under suitable condition, the whole fruits and vegetables, or immediately we should process them to produce juice, to produce slices, canned slices, fresh cut fruits and vegetables, and packaging is to be done. The canning can be done. So processing, either we should do a processing, immediate processing, or we must find out some suitable means of storing them so that these whole fruits do not lose their characteristic shape, texture, as well as the organoleptic qualities, different flavor, etc. The fruits and vegetables are characterized by their high water content. We have already stated that, and presence of free sugar. So if sugars, monosaccharides and disaccharides are abundant, once the microorganism can penetrate inside the fruit by crossing the surface is very smooth, and some waxy materials are there on the fruits and vegetables which can repel water. So free water in case of fresh fruits and vegetable is not available for microorganism. But once the surface becomes porous due to, as the over ripening takes place of the fruits and vegetables, and respiration, due to respiration and perspiration of water, the surface becomes porous and rough. Then microorganism, this free water is available for this microorganism, and they can penetrate even inside, and they find abundance of this medium, these monosaccharides and disaccharides, and they can quickly multiply. Enzymes, indigenous enzymes are also present, which also lead to destruction of the fruits and vegetables, because the plant wants its seeds to be exposed to the environment and come to the soil so that new plant can grow. So there are enzymes which can destroy this outer fleshy layer of fruits and fruits to expose the seeds and to facilitate the process of growth of a newer plant. So enzymes Indigenous enzymes also responsible for decay or senescence of the fruits and vegetables. The freshness of the fruits is reflected by a firmer texture and their natural color. Very attractive colors are there for fruits. Pigments like carotenoids, chlorophylls, anthocyanin, and xanthophyll are responsible for color of fruits and vegetables. The other pigments, carotenoid, chlorophylls, these pigments are fat soluble, while anthocyanin is water soluble. This pigment, a large number of different compounds are grouped together in the anthocyanin class, which are glycosides of anthocyanidin, and they are water soluble flavonoid compound. Carotenoids and chlorophylls contain high degree of unsaturation and are susceptible to oxidation. Because of, in case of carotenoid, it is the isoprenoid structure, double bond is there uh, between the two beta ion ring in case of beta carotene. And these, they are highly susceptible to oxidation. Carotenoid, once oxidized, produces free radical and facilitates the oxidation process of the lipid. If lipid substances are there, they can facilitate the oxidation because free radicals become, concentration of free radicals become high, and that accelerates the process of lipid oxidation. So they are pro-oxidants. Sometimes carotenoids are called pro-oxidants. Chlorophyll also susceptible to oxidation because the chlorophyll structure contains a magnesium atom at the center of the porphyrin ring and a phytol chain, which is having also unsaturation. So both these carotenoids and chlorophylls are susceptible to oxidation. Anthocyanin, water-soluble pigment, and it is destroyed by thermal treatment, as well as this anthocyanin uh, undergoes change in color in when pH of the food material is changed. Under extensive condition of pH changes, anthocyanin color is also changed. Under acidic pH, anthocyanin becomes reddish in color, and under alkaline pH, it becomes bluish violet to darker brown. So these two changes due to change in pH in case of anthocyanin takes place. However, a large number of compounds are there in the anthocyanin class. They behave differently under different pH condition. At neutral pH, some anthocyanins form colorless compounds, pseudo-base compounds. Anthocyanins are destroyed by thermal treatment during processing and also by different enzymes. This is the beta carotene structure. It is a precursor of vitamin A. The plant does not contain vitamin, but contains vitamin A, but contains the precursor of vitamin A. Once we consume the plant material containing vitamin A precursor, then in our body, we can synthesize this vitamin A. Retinol. Retinol is produced from this beta carotene. Whereas lycopene, which is another carotenoid pigment present in tomato, is not a precursor of vitamin because these two rings, in case of lycopene, are open. So retinol cannot be produced by the hydrolysis from the middle of this long chain, unsaturated chain, isoprenoid conjugated double bond structure. These are the structures of chlorophyll A and chlorophyll B. Chlorophyll A and chlorophyll B are plant chlorophylls. There is a central magnesium atom in both these two structures, and it is surrounded by this heterocyclic pyrrole ring. So it is a porphyrin structure. Porphyrin structure. The magnesium atom is separated out, and the chlorophyll becomes olive green when it is treated with acid. That is why when we cook the food material by covering the surface of the vessel with a dish or soap, and the free acids which are evaporated, volatilized due to heat treatment, and once they come at the top surface and then condensed back into the food material again by making the food acidic, the chlorophyll color changes, it becomes olive green. So once magnesium is separated under acidic condition, replaced by a hydrogen atom, it forms pheophytin and it becomes lighter in color, where in case of if the pH is alkaline, then the color becomes dark green, bright green. It is different changes take place under acidic and alkaline condition, and the vegetables which contain chlorophyll, their color is also changed under such conditions. Now, causes of spoilage of fruits and vegetables. We can grossly classify them under two different heads. One is abiotic type of spoilage, abiotic causes of spoilage, and another is biotic cause. The abiotic causes are temperature and humidity. Temperature, high temperature or low temperature. Temperature, according to the Van 't Hoff rule, the temperature per 10 degree centigrade rise in temperature, the respiration rates of fruits and vegetables become nearly double. So higher temperature means rapid decay of the fruits and vegetables. However, this temperature also in some other way can cause harm to the fruits and vegetables. Abiotically, that can also harm the fruits. If the temperature is high, then the watery portion inside will put enormous pressure on the fruits and vegetables, and the water vapor may come out, making the fruits and vegetables softer. As it becomes softer, the degradation of the fruits and vegetables starts. So it is abiotic means. However, temperature also responsible for respiration, which is a biotic change. Lipid oxidation. Lipid oxidation is another thing where a lot of hydroperoxides, peroxides, these are generated, and rancidity takes place. If food material contain the higher level of that higher range of lipids, and those lipids, triglyceride containing fatty acids which are unsaturated, then that lipid oxidation takes place and that perishes the fruits and vegetables. Sugar amino acid type of reaction, Maillard Browning reaction. So different compounds, a large number of different compounds by this Amadori rearrangement reaction, those are produced, which imparts a different color to the fruits as well as produces toxic substances. That is another abiotic change. Changes in pH. pH change also causes spoilage to the fruits and vegetables. Mechanical shock and bruising that exposes the surface of the fruits and the polyphenol oxidase system in due course. They change the color, and microbial attack may also take place. Overall change is that result is that the fruit is spoiled. Protein degradation, another thing, hydrolysis of protein also is responsible for spoilage of fruit. Pungent smell within the food may develop. Biotic changes, respiration, major cause. Respiration is biological oxidation of carbohydrate to produce carbon dioxide and water and heat energy. So respiration is the biotic, and respiration is dependent upon temperature, as I have stated earlier, and also humidity. And there are other hormones like ethylene, a plant hormone which is produced from methionine, and that plant hormone, if present within the vicinity of the fruits and vegetables where it is stored, then respiration rate is accelerated. A large number of different factors which accelerate the respiration process. As the respiration is extensive, the changes, the spoilage is also rapid in case of fruits and vegetables. Microbial attack, different bacteria, different type of bacteria, yeast, molds, etc., which can cause spoilage of the fruits and vegetables. Now comes the storage of whole fruits. If we want to store them, these whole fruits, we have to find out some suitable means by which all these abiotic and biotic changes can be controlled. Low temperature storage, which is a chilled storage, that is at 0 to 5 degrees centigrade. Just after harvesting, what we do is, if to minimize the field heat, we do a pre-cooling operation. That pre-cooling can be done by room cooling method, by hydro cooling, by air cooling, air blast cooling, by transit cooling. Different types of cooling techniques are there. And if to minimize the field heat, just after harvesting, we cool down the fruits and vegetables, and then we take it to the storage. Now, storing at low temperature is different from lowering the field heat by cooling. That is a pre-cooling technique, but here it is a storage, long-term storage at 0 to 5 degrees centigrade. Next is freezing. That freezing can be done at minus 18 degrees centigrade or below. Freezing and refrigeration, these two things are different. So freezing can be done at very low temperature, minus 18 degrees centigrade or below, can be as low as minus 23 degrees centigrade or so. And that can completely control the growth of microorganism. In case of low temperature storage, that is chill storage, the temperature is 0 to 5 degrees centigrade, where the psychrophilic microorganism can grow. But in case of that freezing temperature, when we apply that freezing, the growth process is completely stopped. Cauliflower can be stored at minus 18 degrees centigrade for about 2 months or so. Vacuum packaging is another such technique. If we take out the atmospheric air, which contains oxygen, oxygen is another factor which favors the respiration process. If oxygen is present surrounding the fruits and vegetables, then the respiration process is also quicker. So if we apply a vacuum and the atmospheric oxygen is not available, the products can be stored for longer time without any degradation. Here the product is placed in an airtight pack and the air sucked out and the package is sealed. By removing air from around the product, the level of oxygen in the packaging are reduced, impeding the ability of oxygen breathing microorganism to grow and spoil the product. The lack of oxygen also reduces the amount of spoilage due to oxidation. For example, the process that causes apple and bananas to turn brown can be prevented by the technique. When we apply a pre-cooling of the fruits and vegetables just harvested as the first post-harvest operation, followed by we can do a washing just before the processing. Washing means washing with disinfectant. The surface microbial contamination is enormous in case of fruits and vegetables, and thorough washing in the processing zone is needed. Huge quantity of water is required. This water either without any disinfectant or with disinfectant, but effluent generated, volume of effluent generated is very high in the processing industries of fruits and vegetables due to this washing stage. The chlorine can be used to a level of 100 to 150 ppm and a pH of 6 to 7. Chlorinated water, chlorine dioxide can be used, ozone can be used, cationic water, this acidic electrolyzed water can be used, the paracetic acid, that is those disinfectant can be used, and washing can be done. And just after washing, we can go for processing. But storage does not require a thorough washing to that level, but pre-cooling is needed. If we do a washing, the microbial load can be lowered. The controlled atmosphere and modified atmosphere storage, that is very popular because for some time, though that time is not so prolonged, We can use controlled atmosphere and modified atmosphere storage. The oxygen percentage of air is around 21%, and carbon dioxide is around 0.03%. Now, controlling the atmosphere means lowering the oxygen percentage and increasing the carbon dioxide percentage. In case of modified atmospheric storage, the modification is done and the change is precise. We can control from time to time to maintain that level of oxygen and carbon dioxide. To remove oxygen from the vicinity of the fruits and vegetables, we use nitrogen flushing. So gas flushing is another such technique. Modified atmosphere packaging differs from modified atmosphere storage, that the fruit material, individual fruit material or bulk fruit material can be packed by modified atmosphere condition. Gas flushing with nitrogen to remove oxygen can be done. The last one is high oxygen modified as atmosphere packaging. So far, we have said that oxygen facilitates the respiration process. But when oxygen concentration is very high, then it prevents all those processes, and particularly the fermentation. The fermentation is another such thing which takes place if the fruits and vegetables are stored under favorable condition of fermentation to take place. The fermentation occur and produces ethanol and carbon dioxide, and the typical off flavor is developed within the fruits and vegetables. The high concentration of oxygen can prevent that fermentation process. And above all, what type of technique to be adopted for storage of fruits and vegetables depends largely on the type of fruits and vegetables and how long you want to store those fruits and vegetables. And at the same time, after storage, for what purpose those fruits and vegetables will be used, for either for processing to produce some another fruits and vegetable based product, or directly cooking, kitchen application within the kitchen, or raw consumption. So it depends upon the utilization what type of this technique should be adopted. Thank you.